Mr. Heffern here. Here's a second converging lens problem. This time we've made it a little bit more difficult. We put the object closer to the lens than a focal length. So this time we'll have a 2 centimeter tall object, number 2, and this object will be 3 centimeters from the lens, and we'll change the focal length to be 6 centimeters. And we'll use 2 or 3 rays to find out where the image will be located. Alright, so the first ray I like to do is the one that's parallel to the principal axis. Okay, so this big dotted line moving across here, that is the principal axis, and that is going to reflect through the focal point. So I'll just do that right here. Okay, and this time we'll have to draw an extension line which moves away from the focal point back this direction. And to show that that's an extension line, I'm just going to change it to be a dashed line. There we go. Okay. The second line that we're going to do is going to be through the optical center, like this. Okay. And we also have to draw an extension line for that one, which is going to come back like this. There we go. There, perfect. And we'll make that also a dashed line. There we go. Now, if you want to do a third line, you can, but you don't have to. But if you had a line which was from the head towards the lens, like this, from the focal point in front, it will bend to be straight, like this. And if you draw its extension line, like that, you will notice that it also intersects with the other 2 lines. Okay, let's make that dashed as well. Good. Okay, so we're definitely expecting to get an image over here, which looks like it's going to be bigger, and it's going to be in front of the lens, which means if you try to put a screen here, you can't see the image on the screen. So it's going to be virtual. So here we're going to get an upright image, not inverted. It's going to be virtual because we can't put it on a screen anymore, and it definitely looks like it's going to be larger this time. There we go. Okay, so we got virtual, larger, and uprights. So now let's see if we can find the answers mathematically as well. Okay, so we're going to use the Lensmaker's equation first. So our distances are 3 and 6 for the focal length. So let's just plug those in. So I'm just going to grab that formula and we'll pop it in right here. Okay, so the focal length is 6 centimeters. The object distance is 3 centimeters. There we go. And we're just going to subtract that to the other side. So subtract the 1 over 3 centimeters to the other side. There we go. Now 6 and 3 have a common denominator of 6. So that's going to be 2 over 6. And 1/6 subtract 2/6 is negative 1/6. So we're going to get negative 1/6 for this. Okay, so now if we cross multiply or flip both sides of the equation, we are going to get di of exactly negative 6 centimeters. There we go. So let's just see if that makes sense in the diagram. So negative for lens means on the same side that your object's located, unlike a mirror, which means on the other side. And we take a look. Yeah, it looks like our image is twice as far from the lens as our object. So if this is 3 centimeters, then yeah, it's going to be 6 centimeters away. In fact, it seems to be standing over the focal point. So it looks right. Now we're going to find the image height and the image magnification. So we just have to fill this in as well. So we know the image distance now is going to be negative 6 centimeters. Okay, so plug that in. We know the object distance is 3 centimeters. The object height was 2 centimeters. And so now we're just going to take these two parts of the equation down here and cross multiply that 2 centimeter up to the other side. And so now we're going to find our height is going to be negative of negative, which is positive. 6 times 2 is 12, divided by 3. We're going to get 4 centimeters for the height. So it's going to be 4 centimeters tall. Now if we grab two other portions of this equation, we can find the magnification. Okay, so let's see. There we go. Negative of negative 6 is positive 6, divided by 3 is 2. So our magnification is going to be exactly equal to 2 times what it used to be. So we double. There we go. And if we take a look at the picture, yeah, it looks right. The image does appear to be twice as big as the object, so that worked. Alright, I hope this helps for using a converging lens when you are closer than one focal point. So once again, here's the math, and you can always rewind the video and take a second look at it and how to do the equations. Good luck.